So far we've been talking about the serial interface, using it to send data from the Arduino to the host. But it can be used in the opposite direction, so we'll talk about that. So that can be useful a lot of times, to be able to take data at the host and send it to the Arduino. It's great for user interfaces, right? If you want to send commands manually, you type in a command and have the Arduino do something as a result of, in response to your command, you might use a serial interface, want to type something and send it to the Arduino. So the way you do that is, again, you do it through the serial monitor. The serial monitor, you can see it see up here, is at the top of it. Right now I'm just showing the top of that serial monitor window. At the top there's an entry area where you can enter text and click on send. So you type some kind of text, some type of characters, you click on send, and that data is sent via serial over to the Arduino. So you can use the serial monitor to send data as well as receive data. So when data is sent, it goes into a buffer in the Arduino until it's read. Because maybe when you send data, the Arduino might not immediately receive it, right? When it receives the data, when it wants to read the data, depends on the code, right? Maybe the code's busy doing something else when you do the send. But the data, it's held inside a buffer inside the Arduino until it's ready, until the code is ready to actually read the data out of that buffer. So there's a buffer in the Arduino of a certain size where data can sort of be held temporarily. Now, there's a function in the serial library called serial.available that is used to see how many bytes are waiting in the buffer. And you need this because, again, this is a sort of a synchronization issue between the microcontroller and the human. Or not necessarily human, right? Because from the point of view of the Arduino, it could be receiving data from a human through the serial monitor, but it might be receiving data from another microcontroller, right? Who knows where it's receiving data from. But when it's receiving data, it can't just read data if no data is available. So typically, before the Arduino tries to read the data, it should check to see if the data is available. So it calls this function called serial.available, which will return how much data is available in the buffer waiting to be read. Here's an example. Int byte num equals serial.available, and just simply returns the number of bytes that are available in the data in the buffer waiting to be read. So when the Arduino wants to read a byte out of the buffer from the serial communication interface, it calls serial read. So inside your code, you'd call serial read reads 1 byte from that buffer, that receiving buffer. So in this case, int bval equals serial.read, and bval will be assigned to whatever that byte is. Notice that bval is an integer, not a byte. Integer is actually bigger than a byte. The reason why it needs to be bigger than a byte is because it also has to have the option of returning a -1. A byte can't have it be a -1. It has to have the option of returning a -1 if no data is available. So in addition to reading 1 byte, you could read many bytes at a time. So serial.read will read 1 byte, but you might want to read many bytes. Now, if you read many bytes, you'd call serial.readBytes. That reads several bytes out of that buffer, that receiving buffer, but it writes those bytes into a new buffer that the programmer specifies. So one of the arguments to read bytes is going to be the name of a buffer that you want the data to go into. So read bytes will read out of the built-in receiving buffer and write those bytes into the buffer that you specify so you can access it later. As an example, let's say I say car buff 10. So that gives me a buffer called buff, which is 10 characters long, or 10 bytes long. So it can fit 10 bytes. Then I call serial.readBytes, and I give it 2 arguments. Buff, which is the name of the buffer I just created, and 10, which is the number of bytes that I want to read. And what readBytes will do is read 10 bytes out of the receiving buffer and place them into buff, the buffer that I specify. And I can access that buffer later and do things with the data. Thank you.